Hello and welcome to lecture 17 of this series. And today it's a very hot day, so it's appropriate. We will be dealing with an unusual class of synthetic aroma chemicals, of which I have three here. They're called the marine notes. Now the term marine requires a little bit of explanation and is to some extent a bit of a contrivance. When we talk about the smell of the sea, we're really talking about various different things. We're talking about the smell of decaying things by the sea, namely algae or, for that matter, fish or shrimp or something. And those are not particularly pleasant smells. Then there's what the French called an iodine odor. I'm not sure what exactly is meant by that. It is true that iodine, tincture of iodine dissolved in some solvent, does have a peculiar smell. Whether one gets that by the ocean is questionable. But at any rate, that's another type of marine smell. And then the third type of marine smell is the one that comes from fresh shellfish, like fresh uncooked oysters, which I'm very fond of. And that's rather metallic, really. It would be a good description. When I lived in Nice, I used to have oysters for breakfast whenever I had a chance. And oysters for breakfast is really quite something. You have decaying matter, no good for perfumery. Although there are some perfumery notes that smell like harbor bilge. There's a compound called marinil, which smells like the water at the bottom of a ship's hull. But going back in history, the idea of a fresh air note really goes back much further to the 1910s when Ernest Beau, who was a perfumer of French origin but living in Russia, became obsessed really by the idea of recreating the smell of snow. Now, almost by definition, when it's very cold, things do not evaporate and therefore you don't have much of a smell. However, you do have a sensation when you inhale very cold air. It stimulates the trigeminal nerve, which conveys, roughly speaking, sensations of pain. But at very low levels, it gives a feeling of fizz. It is the sensation you get when you drink soda water and the carbon dioxide hits your nose. So Ernest Beau discovered that the long chain aldehydes, the 8, 9, 10, 11, 12 carbon aldehydes, gave that to him, that snowy impression. And famously, they ended up being used in perfumery, notably in Chanel No. 5, which was composed by him, and then became a staple of perfumery. And they are, in a sense, a white background. I completely agree with Ernest Beau that they give a feeling of snow, whether directly or indirectly. Nevertheless, it does work. And some of these materials approach what is now described as a marine note. And in particular, there's one called Floralosone. Now, Floralosone is a really remarkable molecule because although it ultimately doesn't smell all that pleasant, it smells plasticky, it smells sharp, it has a faintly herbal angle, a little bit like basil, but also it has bite, it has that sensation. And Floralosone is considered a marine ozonic note. Now, what's interesting about it is that you can see, because it's ambiguous, it has all these different facets that I've just described. Facets are, by analogy with a cut stone, are the term used by perfumers to denote the different types of sensations that you get when you smell a particular odorant. And it has, it's a very interesting smell. It's a little bit, I mean, by itself, it's definitely very functional. In other words, it's some cheap stuff that they would put, let's say, in the hotel lobby to give an impression of clean. But I can see how it could be used as a aldehyde type brightener in a fragrance. I don't find it really marine at all, and certainly it doesn't smell like ozone in the least. Ozone doesn't smell anything like the sea, and this doesn't smell anything like ozone. Anyway, so this is Floralosone, and it's very useful in metallic floral compositions, which have been fashionable for now about 30 years. The second compound, which is rather less powerful, and in fact I've made the mistake of smelling the more powerful one first, which is never a good idea, is Helioum, which is an interesting molecule because it's derived from heliotropin, which is a very soft, powdery mimosa type smell. Vaguely bitter almonds, floral aspect, but with an edge, with more backlighting, so to speak, more of a white, powdery edge. I remember I once described it as the smell of a silver spoon after you've licked it. I remember as a child, when a grown-up would wet a handkerchief and with their tongue and then rub my face clean. I would hate it. And you can smell, for some reason, you can smell that best on a metal spoon, on a silver spoon in particular. So that's kind of silver spoon smell. Now, how is that marine? I'm not sure it's marine, but they're welcome to call it marine if they want. And the third one, which in my opinion is by far the most interesting and the most marine of these three, is called Calone. And there I was trying to get it out of the bottle. It's actually a solid. Now, Calone is a remarkable molecule both for its history and for its uses. It's a dioxazepine, meaning a 7-membered ring with 2 oxygens, and it was discovered, or at any rate patented, in 1965 by Pfizer, the pharmaceuticals company, who make a lot of related compounds called benzodiazepines, which are basically the same structure except with the ring has 2 nitrogens instead of 2 oxygens. Now, benzodiazepines are tranquilizers and hypnotics. They make you sleep. And it's interesting that they made this molecule at Pfizer. Makes me think that they must have been looking for another benzodiazepine but without the nitrogens. And instead of making a good hypnotic or a tranquilizer, they ended up with a terrific odorant. Now, whether by coincidence or not, roughly at the same time, Pfizer bought a venerable fragrance company, French fragrance company, called Camille Albert Lalou, dating back really to the 1830s. But Camille Albert Lalou was bought by Pfizer, and this newly discovered oxipine was given the name Calone, C-A-L-O-N-E, Cal standing for Camille Albert Lalou, and One presumably for a ketone. Calone 1951, it was called to be exact. Now, Calone has a very interesting odor profile. It's a very smooth, metallic, slightly floral, very abstract, I mean very, very much unnatural smell. And in dilution, it's extremely powerful. It's used at 0.1%. in fragrance. And it really does give a silvery sheen to it. Now, the patent was 1965, and even though the Calone is called Calone 1951, I'm not sure where the 1951 comes from. And pretty much nothing happened to this note. It was used in tiny amounts in various floral fragrances between 1970 and 1990. And in 1990, something quite remarkable happened, which is that somebody put a big slug, and this somebody is called Yves Tanguy. He's a perfumer at Man. And he put a good slug of Calone in a fragrance which is now discontinued, called New West. And that note of fresh air, marine, whatever you want to call it, watery, it's got many names: marine, watery, fresh air, oceanic. That note caught people's imagination immediately, and it became a huge success. Now, a year later, another fragrance came out called Escape by Calvin Klein, and that one is, even to this day, really my favorite in this particular genre. So this is 1991. It was composed by Claude Deer at what was then Quest. And it's a very classical fragrance, but it has, like New West, a slug of Calone in it. And it was as if it had been an ancient, a very well-rehearsed composition had been suddenly sprayed with some sort of silver paint. And it was a hybrid. It was artistically wrong, but it was interesting because it illustrated what Calone could do to just about any fragrance. And indeed, a few years later, the big success for Calone came, and it was Issey Miyake. So this is called L'Odyssée. Came out in 1992. It was composed by Jacques Cavalier. And it's an absolutely brilliant piece of work, even though I really don't like it. It's superb. The reason I don't like it is actually because for some reason I don't actually smell the full fragrance. When I smell it and I describe it to my colleagues, they're clearly smelling something different. They're smelling a much more floral thing with a marine note in it, whereas I smell just the marine. I essentially just smell the Calone, and I don't find it particularly good. But what was interesting about it was that the inspiration of it came from Issey Miyake himself, probably, in my opinion, one of the great, possibly the greatest genius in fashion of the late 20th century. And Miyake, who is always a purist, wanted a perfume that smelled of water. And of course, water is odorless. And so there's this kind of weird effect that happens when you try to translate modalities between one area of art and the other. And in architecture, for example, this happens very often in labs, research buildings, somebody at the top says to the architect, "We want the building to symbolize openness," and the architect immediately translates that into architecture terms, and that becomes glass. So that's how you end up with buildings made for science, where the labs have all glass walls and everybody can see everybody else. And of course, the first thing people do is put paper on the glass walls in order to have some peace. Now, in the field of perfumery, when you say water, when somebody, the importance of Issey Miyake, says, "I want a perfume that doesn't smell of anything, that smells like nothing, that smells like water," they say yes, 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 and then they go away and think about it, and they say, "What do we got that smells kind of like water?" And at the time, Calone was pretty much the only thing that had that really strong watery feel to it. And so Chantal Rose, the art director, and Jacques Cavalier got together and produced this brilliantly conceived floral fragrance in which the Calone fit perfectly. And that became, for about 10 years from 1992, it became the fragrance for people who hated 80s fragrances. From 79 to 1990 were huge, fruity, spicy, heavy affairs, and this was the exact swing of the pendulum in the other direction towards a transparent, luminous, almost evanescent thing. I must say I was rather fond of the big, vulgar 80s fragrances, but anyway, this was as if fragrance went on a diet and started wearing only white. So it was a huge success. In the great tradition of what's called I&D, imitation and development, many fragrance companies got into the act and produced other compounds that were variations on the Calone structure, which had been, of course, discovered by accident. And they did what's known in the trade as homologous series, namely you take one carbon and you replace it with 2 carbons, 3 carbons, and 4 carbons, and you find out whether they're more powerful, whether they're in the patent for a start, and whether they work better or differently. And this is known as methyl, ethyl, butyl, futyl. And indeed they produced some other novel compounds, none of which have had the success of Calone, and perhaps that is divine justice in some ways, since Calone was the first one. So to finish off on a more scientific note, which relates to the previous lectures, this particular article on the synthesis of marine notes perfectly illustrates the weird mindset of fragrance chemists when they set out to develop new molecules. They both know perfectly well that structure does not predict odor, but they have no better guide than that, even though it's not a very good one. And in this particular article, they freely admit it. They say, correctly, that olfactory receptors were discovered in 1991 by Linda Buck and Richard Axel. But the mechanisms of odor and receptor interaction are yet to be understood. All true. Predicting the odor properties of a new molecule by rational design remains challenging. Challenging, I think, in this particular instance is perhaps an understatement. In fact, references 15 and 16 by Charles Sell say quite clearly that it is essentially impossible to design a molecule from shape, and that it is unlikely to become possible anytime soon. And then blithely they say, nevertheless, the best solution to date for rationalizing the activity of odorants is the use of an olfactophore model, which corresponds to the pharmacophore in drug design. So, nevertheless, the best solution, meaning the best with no competition, and it still doesn't work. So what is the structure-activity relationship that they develop for methyl group? Some distance of 2.95 angstroms away from an aromatic ring, 5.5 angstroms away from a ketone. Summarized in this figure, hydrophobic pocket, aromatic ring, spacer, and a ketone that forms a hydrogen bond. Now, I absolutely guarantee you, in fact, I can think of half a dozen, that there are hundreds of odorants, most of them not marine, most of them, in fact, lily of the valley compounds that follow this particular scheme, and therefore this is complete nonsense.